Okay, let's get started. Thank you very much for joining everyone. It's fantastic to see so many people here. My name is Dale. I'm a developer for IBM, and I spend a lot of time working on STEM activities, developing STEM resources, and working with schools to help them introduce technology concepts to their students, like AI that we're all here to talk about today. So my plan for today is to try and give you a bit of an introduction to artificial intelligence and machine learning, because there's a lot of misconceptions out there about it. I think for my generation, if you say AI, the general public, it brings to mind things like Skynet and the Terminator. That's not a reference my kids would come up with, but maybe they would come up with things like Wally. There's a general assumption that AI means sci-fi, it means future, it means robotics quite often. And as you'll see as we go through this afternoon, that's not really the case. Now you can do AI projects with robotics, but you don't have to. They're not synonymous, and a lot of the AI systems that you use every day don't involve any robotics at all. So my hope is to try to help you to see what AI really is, how it impacts all of our lives, and how you can get started building things with AI yourself. So the plan for this afternoon, I'm going to start by going through some terminology. Actually, before I go through the agenda quickly, there is a chat system in WebEx. So if you've got any questions as we go through, please put them in the chat. I'm going to save them all to the end, but I would say put them in the chat as you think of them so you don't forget. And then I'll leave some time at the end and I'll go through and make sure that we've answered all the questions that you've had. So yeah, please, as we go through, do ask anything that isn't clear. But yeah, so what we're going to do, I'm going to start by going through some terminology. I want to get to a point where you all feel comfortable, you understand what these words, artificial intelligence, machine learning, what this all means. And then I'm going to get you to try making some stuff yourself. So we're all going to have a go at making an AI project. If we get time, I hope we'll have a chance to make 2 different projects, but we'll see how things go. Maybe we'll just do one, we'll see. And at the end, I want to show you some other projects that students that I've worked with have made, so you get a broader idea of the kinds of things you can make. So that's the plan. But let's get started. What does artificial intelligence and machine learning actually mean? And why do we have 2 different names for this stuff? Artificial intelligence, AI. That's the name that, oh, sorry, I'm distracted by the chat. Can anyone hear me? I'm assuming that people can. Is that, oh, okay, brilliant, thank you. I will press on. What was I saying? AI, artificial intelligence. That is what we call projects where we get a computer to do something smart, because computers are artificial, and if you do something that looks smart, that looks like intelligence. AI doesn't mean anything about the technology or how it's done. It's a description of your objective, of your goal. And there are loads of ways you can get a computer to do something that looks smart. But our favorite way is machine learning, ML. That's our favorite way. That's the most powerful technique that we have. It is one of the ones that we're all most excited about. In terms of all the different ways of making AI projects, machine learning is the one that you hear us talk about the most. Now, I hope we'll get time today that I'll show you a machine learning way of doing an AI project, but I'll also show you an alternative so you can start to get a sense for when machine learning is a good fit. But that's why we've got 2 names for this kind of thing, because there's a difference between what you get a computer to do and the way that the computer does that thing. AI is what we're calling the thing we want the computer to do, and ML is one of the technologies, one of the techniques, the way that the computer can actually do it. So one way we get a computer to do things is using coding. And I imagine a lot of you will be able to sort of recognize where I got this screenshot from Scratch. And Scratch is a really nice way of explaining principles of coding. But this idea that we tell a computer exactly what we want it to do, we tell it the order that we want it to do those things in. You know, do this, then do that, move 10 steps, then turn 15 degrees, then say hello, then change size. Now, That idea of breaking down a task step by step is a very traditional idea of coding, but machine learning doesn't do that. That isn't how machine learning works. Machine learning is different. With machine learning, you're not telling the computer how to do the task, and you're not writing it step-by-step instructions. Instead, with machine learning, you show the computer examples of how you would do the task. You show it what you want the computer to be able to do over and over and over again, so that the machine can learn from those examples how to do that task for itself. Let me give you an example that hopefully makes that make a bit more sense. So have you ever seen a computer recommend something you might like? Like when Netflix tries to predict what TV show you might want to watch next, or Spotify tries to predict what song you might want to listen to next, or when YouTube or TikTok try to predict what video you might want to watch next. That is an artificial intelligence task because of all the millions of videos in the world, knowing which ones you would enjoy, that's kind of smart. So we can call that artificial intelligence. So how do they do that? Well, YouTube could get someone to write some step-by-step instructions for how to choose videos that you might like. Like maybe they could write a rule that the computer should choose any videos that mention certain words that I'm interested in the title or the description. Now, technically that would work, and that would be AI. They could write some rules, and those rules would choose some videos, but it would probably be pretty bad at it. It would probably pick a bunch of videos that you're not interested in, and it would probably miss loads of videos that you would really love. So they don't do it this way. Instead, they use machine learning. And remember what I said, machine learning is when you get a computer to do something by showing it examples. So for the computer to learn how to predict if you would like a video or not, we need to give it examples. We create two big buckets, and in one bucket, we give the computer lots of examples of videos that you love. In the other bucket, we give the computer lots of examples of videos you don't like, and the machine can learn from those examples how to recognize what sort of things you like and what sort of things you don't like. So every time you click thumbs up on a video, or even if you just watch it all the way to the end, you're putting that video in a bucket of videos that you love. Every time you click thumbs down on a video, or even if you just skip it really quickly, you're putting that video in a bucket of videos you don't like. And the computer is learning from all of those examples how to get better at finding the things you like. So that's how sites like Spotify and Netflix and YouTube and TikTok work. Working out what you would like, that's the AI project. And they're doing it using machine learning by using examples of what you like and what you dislike to teach, to train for the computer to learn from. Another way you commonly see this shown is as like a Venn diagram. So put like this, think of it in terms of all machine learning projects are AI projects, but not all AI projects use machine learning. The reason we leave this sort of space here is to show that there are other techniques that people could use, other techniques to do AI that aren't necessarily machine learning. And like I said, I'll show you an example in a bit later. And I'm not going to get into it deeply today, but just quickly, if there's other terms you've heard of, so if you've heard people talk about neural networks, that's one particular way of doing machine learning, because we've got different ways of getting a computer to learn from examples. So neural networks is one that you quite commonly see mentioned by the media and the news. And actually of neural networks, there's one particular type of way of doing neural networks that we call deep learning. So if you hear or see in the news stories about deep learning, it's a type of neural network, which is a type of machine learning. So what we're going to be talking today is mostly about machine learning, because like I said, that's kind of our favorite way of doing AI projects today. So that's enough jargon. That's kind of, I think, if you can get a feel for just what we mean when we say AI, a project where we get a computer to do something smart, and what we mean when we say machine learning, which is where we get a computer to do something not by giving it instructions, by giving it examples to learn from, then you know enough for us to get started. So, like I say, what I want is for you all to give this a try for yourself. So the project we're going to start with is based on this. So this is my drawing of a glass. Not a great drawing, but bear with me. So how would you describe this? Well, this is empty. And if I fill it with liquid, if I fill it with water, all the way to the top, then you would describe this glass as full. But what if I fill it with a random amount of water? So if I just pick some random amount like this, how do you describe this glass now? Is it half full or half empty? Now that simple job is what we're going to try and get a computer to do. You're going to teach a computer to be able to describe a glass based on how much water is in it. And the way you're going to do this is using machine learning as the technique. So you're going to train a computer to be able to describe if a glass is half full or half empty. Now, I would love for you to do this for yourselves, but if you'd rather just watch, I am going to show everything on the slide. So if you'd rather just follow along, that's totally fine. I'm going to try to go slowly enough that if for people who do want to try this for themselves, they can keep up. But if I'm going too fast, please let me know in the chat so I know to slow down, so that I know if I'm leaving people behind. So what I'm going to do is I'm going to sort of walk you through step by step how you can make a machine learning project. So that's the plan. So to start with, if you do want to sort of do this with me, please open a web browser and go to machinelearningforkids.co.uk. And I'll put that in the chat so you don't have to type that long address in. There we go. So I'm just waiting a minute because I know it's quite a long address to type in. So I'm going to give everyone a moment to catch up. Like I say, these instructions are going to be posted afterwards. So if you do want to try this later, that's totally fine. If you want to try it now with me, brilliant. So I think that's enough stalling. Let's get started. So please click on the Get Started button. It's that blue button down there on the bottom left. Now, if you've cheated and you've already logged in, then click Log Out at the top so that Get Started button appears. Okay. So now please click on Try It Now. It's that bottom blue button. Now, what this lets you do is use the site for about 4 hours without having to create an account or worry about usernames or passwords. So that's commonly how this stuff is used in the classroom. It means you don't have to worry about getting your students to remember a password. We will come back later this afternoon and I'll show you how you can log in, because if you want students to be able to come back and finish a project like in a following lesson and you don't want everything deleted after 4 hours, then it is useful. So we'll come back to logging in later, but for now, please just click on Try It Now. So the site is project based. So this is your list of projects. So you haven't got any yet. So the first thing we're going to do is clicking on that plus button in the top right hand corner where it says add a new project. So now we need to give the project a name. Now, like I said, what we're going to do here is train a computer to describe a glass based on how much water is in it. So call the project something like describe the glass. The name doesn't really affect how the computer's not going to affect how it's learning based on the name. This is just for us. So don't worry about spelling or anything like that. So yeah, type in describe the glass into that project name box. Now, there are lots of things computers can learn to recognize. We can train computers to recognize the meaning of text or of sounds or of pictures. But for this project, we're going to be training the computer to recognize the meaning of a number, because we're going to give it the number for how much liquid is in the glass. So please choose numbers from that list there. So next, we need to tell the computer how many numbers we're going to give it to recognize. So to start with, please click on that blue button that says add a value. So we need to give this number a name. So I've called it percent because we're going to be giving the computer a number from 1 to 100 to tell it how much water is in the glass. Again, the spelling, the actual name isn't going to affect how the computer learns. This is just so that we know what we're doing. So don't worry too much about it, but please type something like percent into that value box. And then now we need to say what type of value this is going to be, because we can give it just like multiple choice values for some projects. And I'll come back to you later when you would want to do something like that. But for now, we're just going to be giving it a number from 1 to 100. So choose number in that list of types of value. So what we've got here is we're going to create a new project called Describe the Glass. We're going to be training the computer to recognize the meaning of numbers, and we're going to be giving it one number that we've called percent. That is a number from 1 to 100. So once you've got all of that, you can click on the Create button. If your screen is small, you might need to scroll down to get to it, but it's down on the bottom right there. And that will take you back to your list of projects, and now you've got your first project. So please click on where it's got the name of the project. So you can see I had sort of described the glass, but whatever you called yours, please click on that now. So that gets you to the main menu for your project. And these are the main phases of a machine learning project, where we collect examples that the computer can learn from. We use those examples to train a machine learning model, and then we use that machine learning model to make something. So that's what we're going to go through this afternoon. So to start with, we need to prepare those buckets that we're going to be putting our examples into. So please click on that first button on the left that says Train on it. So we need to create two buckets, one for all the examples of when the bucket is half empty, and one for when the glass is half full. So please click on the plus button in the top right that says Add New Label on it. So we need to give this first bucket a name. So please type in half empty. And again, like before, the spelling doesn't matter. The computer's not going to be learning from the name. This is just so that we know what we're putting into that bucket. So yeah, something like half empty, though, would be good, please. And once you've done that, please click on the Add button underneath. And that's our first bucket. So we need one more. So please click on that plus button, the Add New Label button again, up in the top right. And this time, call the second bucket half full. Again, don't worry about the spelling, but as long as you recognize what it means, that's the important thing. And when you've typed in that, please click on the Add button underneath. So those are our two buckets. We're going to fill these with examples of numbers that for the amount of water in the glass. So once you've done that, please click on the Back to Project link. That's the blue link up in the top left-hand corner there. Now, we're going to skip straight to Scratch for now, so please click on the Make button. Pardon me, it's the third button you can see on the right on my screen there. Now, there are different ways you can make machine learning projects in the classroom, and I'll come back to some of the others later on. You know, if you've got older students, you might want to use Python. But for today, we're just going to use Scratch because that makes it nice and easy, and it's quite a visual way of sort of seeing what's happening. So please click on Scratch 3 for the new version of Scratch. So it's going to tell you that, hang on a minute, you haven't got your training examples yet and you haven't got your model yet, but that's fine. You'll see why in a moment. So just click that white button where it says Straight into Scratch. So what this is going to do is going to open a new window with Scratch in, and it's going to add some extra blocks into the Scratch toolbox for your machine learning project. And I'll show you what we'll do with them in just a moment. So hopefully now you are seeing the Scratch window open. It can take a minute, well, not a minute, it can take sort of 10 seconds or so. So I'll just hold on so everyone can catch up. So to save time so that you don't have to do all the sprites and coding yourself, I've got us a template ready to give us a bit of a head start. So to get to that, please click on the Project Templates button that's in the menu up there at the top. And that gets you to a list of all the different project templates. As you can probably guess, we're going to be using that first one up in the top left that's called Describe the Glass. So please click on that, and that's going to download the code and the sprites and pretty much everything you need to get going with this project. So the code here is like almost finished, so we just need to add a few bits to finish it off. So we're going to do that now. Now, I assume that a lot of you are going to be familiar with Scratch, so hopefully this all looks reasonably sort of comfortable and familiar. But I'll show you exactly what to do for each section, so don't worry if this is a bit new to you. So the first thing we need to do is to finish the code for the half-empty sprite. So in that list of sprites down in the bottom right, you can see the second one is called half-empty, so please click on that. Now, this is the button we're going to click on when we think the glass looks half-empty. So when you've clicked on that, try and find the starter bit of code. It looks like this. It starts when this sprite clicked, and it's sort of like an orangey block and a purple one and an orangey one like this. If your screen is small, you might need to scroll around to find it, but it is there. So try and find where that starter code is. I'll give you a sec to find that. So if you click on the half-empty sprite, that is that one down in the bottom right hand where you've got the list of all the sprites, click on the one that says half-empty, and then once you've clicked on that, find this bit of code. It's the code that starts when this sprite clicked. And then I'll tell you in a second what you need to do to change to finish that off. Okay. So what we want is when you click on the button that says you think the glass is half empty, you want it to add the amount of water that's in the glass to the training bucket for half empty. So that's what this coding is doing. So if you know what you're doing with Scratch, just copy the code picture I've got on the left. If you're not too sure, I've got a video going on the right to sort of show you how to do it. So what we're doing is when this sprite is clicked, we're going to add the variable with the amount of liquid in the glass to the training bucket that you called half empty. So that's why you'll find this dark blue block right at the bottom of the palette. You need to scroll all the way down to the bottom of the toolbox. So I'll give you a moment to find that and to update the code. So this is how we're going to collect our training data. We're going to get you to do it, to sort of play the game inside Scratch. And by clicking on a sprite, you're going to be adding values into those two training buckets you set up a moment ago. So hopefully you've all finished your bit of coding there. So now please click on the half full sprite. Now this is going to be the button that we click on when we think the glass is half full. And we need to do the same kind of update to the coding there as well. So it's that third sprite along in that list in the bottom right called half full. And when you've clicked on it, again, try and find this bit of code that starts when this sprite clicked. Same as we did just now. And once you've found it, we need to make a similar sort of coding change to it as before. So you're adding a new block called add training data. But this time you want to add the variable for how much liquid is in the glass. You need to add that to the half full training bucket, not the half empty one. So I'll give you a moment so you can concentrate. I'll be quiet for a sec. So this is the button for when someone thinks the glass is half full. So what we're doing is when someone clicks on that button, it's going to add the variable with the amount of liquid in the glass to the half full bucket. And make sure that you have chosen the half full bucket because you want the example to be added to the right place Otherwise, the computer will get confused from the training that you give it. So make sure in that, where the little triangle is, you click on that and choose the right bucket name to add the example to. So that's enough coding for us to start training the computer. So if you can click on the full screen button in the top right corner, please, the one with the 4 arrows pointing away from each other. And then click on the green flag. So that's going to play that beginning sort of video intro that I showed you at the start that explains the idea of the project. But once it's finished showing you full and empty, it will pick a random amount of liquid and then show you the 2 buttons that we've just done the coding for. So once you see that, choose whether or not you would describe the glass as half empty or half full, and then click on whichever button you think is right. And obviously there's no right answer here. It's down to how optimistic you're feeling this afternoon. Okay, hopefully everyone has done that now. So I just want to sort of pause to show you what we've done. So please, can you, if you go back to the tab for the training tool, but don't close the Scratch window because we haven't finished yet, but just leaving the Scratch window open, go back to the tab for the training tool, and we'll just have a look to see what you just did. So please click on the back to project link. That's that blue link in the top left corner to go back to the main menu for the project. And we want to go back to, oh, sorry, sorry, someone in the chat just asked if I could repeat that. So we were in Scratch. So what I said is please switch to the other browser window, the other browser tab for the training tool, but don't close Scratch because we need to finish work in Scratch in a moment. And once you're back in the training tool, please click on the back to project link. That's that blue link in the top left-hand corner. So now we're back at the main menu for the project. So please click on the train button, that first button on the left. And what you should see, if this has worked, is the buckets aren't empty anymore. You've got your first example. Now, the number will be different because it's picking a random amount of liquid. But when I tried it, I had 54% liquid in the glass, and that looked half full to me. So I pressed half full, and that example went in that bucket. But this is how we're going to train the computer. Now, one example isn't enough. Computers can't learn from a single example. We need to show them lots and lots of times for them to learn. But I just wanted to show you like the idea of what we're doing here. We're collecting training examples for the computer to learn from. So with that, you can go back to the Scratch window now. And again, don't close the other tab, leave it open, but just switch to the Scratch tab. And just collect lots more examples. So every time you've clicked on a button, it will change the amount of liquid in the glass and then show you the 2 buttons again. So then again, make a choice. Do you think it's half empty or half full? Once you've clicked on it, it will pick a different amount of liquid. So just do that, you know, like, well, we'll do it for sort of 30 seconds, a minute or so. We just need a bunch of examples in each bucket. So I'll leave you to do that while I answer questions in the chat. So if you're seeing 0 showing up in the buckets, it probably means that, and I'll just switch to the screenshot, it probably means that either you didn't copy the variable into the bit of code or you copied the wrong variable in. So as long as you put liquid percent in there, then that's the variable that has how much liquid is in the glass. Right, where was I? Here we go. So yes, oops. So collect a few more examples. There's a really strong pattern in machine learning that the more training examples you give it, the better it gets. The more examples we can give, the more accurate the machine learning model will be. If you want a way to think how to explain that to your students, it's kind of think of it in terms of if you explain something to them only once in one single way, think how much they understand that compared with if you explain the same thing to them multiple times in different ways. You know, that helps it to make sense to them. Computers are kind of the same sort of thing, that the more examples we give it for it to learn from, the better their understanding, to sort of anthropomorphize it a bit. So hopefully now you have got a bunch of examples, and if you want to see them, you can go back to that training tool tab. You will need to hit the refresh button to get the new examples to show up. to see the ones since you last looked. But hopefully you'll see similar to what I've got here, which is a few, some examples in the half empty bucket, some examples in the half full bucket. Yes, so to answer a question in the chat, you do need to refresh. The page doesn't automatically update. So yeah, reload the page to see the examples that you've collected since you last looked. So now we've collected examples, it's time to see what the computer can learn from the training that you've collected. So go back to Scratch and click on the full screen button. We're going to need to do one last bit of coding to get it to learn from the training that you've collected. So this time we're going to do the coding in the prediction sprite. So please find the prediction sprite. It's that first one down in the bottom right-hand corner called prediction. And you need to find the bit of code that starts when I receive question. So this is the code that runs when there's a new amount of liquid in the glass. And like before, you might need to scroll around to find it, depending on how large your browser window is. But it's the one that's got the 3 question marks in, because at the moment what it's doing is it's just having the prediction down in the bottom right-hand corner is always question marks. And we're going to update this now so the computer will actually put a proper prediction in there. So time to do a little bit of coding again. So now where it's got the question marks in, you're going to drag in this block so that it will recognize the meaning of the number we give it. And again, the number we want to give it to recognize the meaning of is that variable with the amount of liquid in the glass called liquid percent. Now, one thing to be careful of here, make sure you pick the block that has got label at the end, not the one that says confidence at the end. We'll come back and I'll show you why and when you use the confidence one a bit later. But for now, please use the one that says label at the end. So what this is going to do is when there's a new amount of liquid in the glass, it's going to use the machine learning model, your personal one that you've trained with only your examples, to make a prediction of what it thinks the meaning of that number is, either half empty or half full, and then it's going to put that in the variable called prediction that is displayed on the screen. One last bit of coding to do. Please find the script that says when I receive next question. It's just to the left of the bit of code we just did. It's got sort of an set prediction to blank in there. And you just need to add one block to the end of it. What this is going to do is tell the computer to look at all the examples you've collected and learn from them. That's when you're actually going to train the new, what we call a machine learning model. Machine learning model is kind of our name for, it represents all the things the computer has learned from the examples you've given it. So this way, what it's going to do is it's going to learn from all of your examples after every new glass. So the longer you do it, it will get better and better and better. So I'll just give you a sec to finish that last bit of code and then we'll give it a try. Right, let's try it out. So back to full screen mode so we can try it out. So that's the top right button, full screen. And then once you've done that, please click on the green flag again so it picks up all of your new code changes. Does mean that, again, you have to watch that beginning little intro that explains the idea of the project. And to answer one of the questions in the chat, the machine learning model will get more trained the more we use it. Yes, and that's a really common pattern for how we do things. You know, the first version of our machine learning model that we used will be quite good, and we try to collect more training examples from as people use it so that it can get better and better and better the more we use it. So this time, what you should see is down in the bottom right-hand corner, you get a prediction, and that prediction is going to be based on the training that you have given it. So everyone, all of you are doing your own separate individual projects. So see what you think. Do you agree with the prediction? Do you think it's correctly described the glass in the same way that you would have? If you click one of the blue buttons at the top, you'll get a different random amount of liquid and a new prediction. So try it a few times and see what you think, and see whether or not you think your machine learning model has been trained the way you would have sort of wanted it to. I'll give you sort of 30 seconds, a minute to have a quick play with that before we move on. So I want to show you what's actually happened under the covers here. So please switch back to the tab for the training tool, because I want to show you what you've actually done, what you've actually built, what I mean when I say a machine learning model. So once you're back in the training tool, please click on that back to project link in the top left-hand corner again. That gets you back to the main menu for the project. And this time, I'd like you to click on the second button, the one that says Learn and Test. Now, there's a button, and again, if your screen is small, you'll probably need to scroll down to see it, but there's a white button there that says Describe Your Model. Now, this will take a few seconds to run, but what that's going to do is it's going to draw you a picture of your own machine learning model and explain what the computer has learned from the training you've given it. So if you click on that, but like I say, it might take a few seconds as it sort of collects it all. So while we're waiting for your diagram to load, I'll show you what happened to mine when I did this. So what it is we call it a decision tree. And it's kind of a tree where you start at the top and then you follow the arrows until you reach the bottom. Now, my tree is really, really simple. But what this is telling me is, where's my mouse pointer? There we go. This is saying that what the computer learned from the examples I gave it is that if the percentage of how much liquid is in the glass is less than or equal to 47.5, it goes, then this statement is true, so it goes down that way, and it would describe the glass as half empty. If that's false, if the amount of liquid in the glass is more than 47.5, it would go down the other way, and it would be described as half full. So that was what the computer learned from the examples I gave it. It learned that less than 47.5 is kind of half empty, and more than that is half full. Now, your diagram will will look different to mine, because you would have had a different opinion, you would have given it different training. Now, your tree diagram will be a lot more complicated if your training was inconsistent. You know, if for some numbers you sometimes called it half empty and sometimes called it half full, then the computer would have tried to learn when you do one and when you do the other. So your diagram would reflect that increased complexity, whereas I seem to be fairly consistent, so my tree came out really, really simply. So, and the other numbers just quickly here to show you to explain what this whole diagram means. 31 means I gave it 31 examples, and the values is saying I gave it 16 examples that were half empty and 15 examples that were half full. So it's a slightly complex diagram, but what this is showing you is what happened under the covers, what the computer learned from the training that we gave it. So the task that you got the computer to be able to do, someone asked in the chat, how do you get to that tree? So from the main menu for the project, you click on that middle button where it says Learn and Test. And then on that page, there's a button that says Describe Your Model, which is sort of quite far down, and it's a white button on the left-hand side called Describe Your Model. And that takes a few seconds to generate you a diagram that looks a bit like that. So the task you got a computer to be able to do was to describe the glass based on how much water is in there. And because being able to describe something is sort of smart, we call that artificial intelligence. And the way you did it was using a technology and a technique called machine learning. You collected examples of when you would describe a glass as half full and when you would describe a glass as half empty. And you use those examples to train the computer to be able to do that job. Sorry, I'm just quickly going to answer one question I saw in the chat. If you're not seeing those buttons, it probably means you haven't yet got enough examples to train a machine learning model, because you need a certain number before the computer can start to learn. So, and you'll probably see that in the what's next sort of blurb up at the top. It will probably say, please go and collect more examples. So sorry if I didn't leave you long enough to collect enough examples to actually get to see that, but I hope from watching the screenshots of mine, you got an idea for the kind of thing you would have seen. So you've made your first AI project. But what I hope some of you are thinking is, Well, hang on a minute, is that it? I have intentionally picked a really, really, really simple thing because I wanted you to actually see everything that happens under the covers. But let's be honest, we could have done this with rules, right? I could have made a decision that, the rule that ended up coming out of my model was 47.5. I could have just chose at the start that I think more than 47.5% is half full. And then I could have made some code like that, and I wouldn't have needed to do any of that machine learning model stuff, right? So, and it comes back to what I was saying at the start. Remember when I said machine learning isn't the only way we can do AI projects? There are lots of other ways. And just writing the rules, writing the instructions to follow is another perfectly valid way of doing an artificial intelligence project. So I would argue that for this particular project, we didn't need to use machine learning. It's helpful so you can see what machine learning is, but there are other simpler ways we could have done it. So why do we have machine learning? When do we use machine learning, and when do we not use rules, step-by-step instructions? Well, typically, we use machine learning when we want the computer to do a task that either we don't know how to describe the step-by-step instructions, it's too complicated for us to know what the step-by-step instructions would be, or that we think it's such a complicated task that the step-by-step instructions would just take too long to write. Where we get excited about machine learning and why we think it's the most powerful technique we have for AI is for tasks where it isn't practical for us to write the step-by-step instructions to do it. And for something like describing a glass, that probably doesn't count. So what I want to do is I want us to try a second project. And this time I want us to do a project that really is much more complicated, that would be quite hard to do by doing rules. And I want to show you actually the real benefit of using machine learning by getting the computer to do something that's really quite complex. So for our second project, we're going to train the computer to understand what we mean when we ask it to do something. So if you've ever used an Amazon Alexa or a Google Home or Apple Siri, then that's the kind of thing I mean. Something that you can phrase your command however you want, and it will understand the meaning of what you've said and then do something. And doing that to cover all the different ways people can phrase a command, that's quite hard to do with rules. So this is the kind of task that machine learning is actually really well suited for. So this is going to be our next project. And again, we're going to do it in Scratch. And again, we're going to make it simple so that you can sort of see what's happening. So we're going to train our Alexa to understand just two commands. We're going to get it to understand when we ask it to turn on a fan and when we ask it to turn on a lamp. So again, please go in a web browser. And again, if you don't want to sort of do this yourself, that's totally fine. You can either do it later or just watch along, that's fine. But do please consider, giving it a go and doing it along with us, but particularly for this one, because I'll explain why in a minute, but having a lot of people doing this would help, and I'll show you why in a moment. So go to machinelearningforkids.co.uk, and if you did the last project with me, you'll be logged in. So please can you click log out, because I want us all to start together, and I'll show you why in a moment, but please click log out so we can all start at the beginning together. So now I want you to click log in at the top there. And the reason is why I mentioned this before. Before we did the project with Try It Now, where you just use the site without registering, you use the site without passwords, and you can use it for 4 hours before your stuff gets deleted. And I said I wanted to show you what the alternative way of using the site was, where you actually do log in. So that's why I want you to log in now, so I can show you the two different ways you could get your students to do it. So please click on the login button. It's that second button in the list there. Right, now I need you all to choose a different username. So I'm going to do this by getting you to pick a number from 1 to 100. The reason why is basically if all of you log in with the same username at the same time from lots of different places, then the firewall I have in front of the site is going to think something weird's going on, and it's going to not let you in. So this is my way around this. I've not done this before, so bear with me. Please pick a number from 1 to 100, and then we're going to put that in your username. So make your username UCL and then a number you've picked. So UCL 10, UCL 50, UCL 99. And then the password is going to be UCL workshop, all small letters. If you've already got an account, please log out and log in with this. I'll show you why in a minute. I know it's a bit awkward, but trust me, it's worth it. So please give this a try now. Log in with the username UCL and then a number, and then the password UCL workshop. And if it doesn't let you in, it probably means you've picked a number that lots of other people have picked. So please just change the number and try again. So I'm going to give you all a second to do that while I check to see how many people are appearing. Excellent. Okay, so if I just drag my browser in front, so what you can see here is, actually, if I go back to the start, so if you're a teacher on the site, you have an extra tab at the top that students don't get, labeled teacher. And in that, there's various things that I'll come back to later, but the interesting one here is student management. So here's where you can create student accounts, reset their passwords, that sort of stuff. So this is how I can see now that you've all started logging in. But the reason why I wanted you all to log in with this account and not with one of your own is because I wanted to show you that you can get students to work together. Because what we're going to do is train the computer to recognize the meaning of text, and we need examples of text to do that. And one nice way of doing that is to get all your students to work on a joint project collectively. So as a teacher, I get this extra button next to projects called share. And if I click on that, it now means that this project is available to all of you. And what I'm going to get you all to do is we're all going to work together on this project and train a machine learning model between us as a group. So that's why I wanted you to log into this class so we can all work together. And partly because I wanted to show you that this is a really nice way of getting your students to combine their efforts on something. So, so if you could click on the Go to Projects button, please. And that gets you to your list of projects. And you should see, oh, sorry, there we go. You should see that project I just shared with you all there. So it's called Smart Classroom, and I've already set up the buckets in there to save us a bit of time. So please click on the project name, click on where it says Smart Classroom. The other thing while you're doing that is that little icon there in the corner. That's what that means. It means that this is shared with the whole class. It's something, it's not your own private project. You're working on it with your classmates. So again, that gets you to the main menu for the project. And I'd like you to click on the train button, please. And you'll see the empty buckets that I've set up for us all to use. So, and again, I haven't tried this before, but we'll give it a go. What I'm going to try and do is split you up into two groups. So I'm going to do this based on your first name. If your first name begins with the letters A through to J, you're going to do fan, and I'll explain what that means in a moment. If your first name begins with a K through to Z, you're going to be doing lamp. So just sort of remember which group. It's not terribly scientific. I'm literally just trying to split you all into two groups. So try and keep in mind, are you doing fan or are you doing lamp? So once you know which one you're doing, please click on the Add Example button for whichever bucket you're doing. So if you're doing fan, click on that left button there. If you're doing lamp, please click on that right button there. So if you're doing fan, lamp people, bear with me a second. If you're doing fan, please type into this text box an example of how you would ask a person to turn on a fan. So something like, would you turn on the fan? Or can you turn on the fan, please? Or please turn on the fan. Don't copy one of mine. Try and come up with one of your own. And you don't have to use the word fan in there. So you could do something like, it's boiling in here, or can we get some air in here, or something like that. But try and be creative. Try and think of your own example. Right, I'll leave you to do that while I talk to the lamp people. Lamp people, same kind of thing. Please try and type in an example of how you would ask someone to switch on a lamp. So something like, please switch on the light, or would you switch on the light? And again, you don't have to use the word lamp or light in there. You could say it's really dark in here or something like that. So I'll leave you to do that while I just check on the fan people. Fan people, hopefully you've come up with an example idea by now. Try and come up with something a bit different. So I did this, it was this a while ago now, but I did this with a class, and my favorite example that one of my students came up with was activate the spinny thing, which was genius, and I never would have thought of that. So don't just sort of stick to what I've done. You can make your example command really, really long or really, really short, entirely up to you. Lamp people, again, try and come up with something different, try and be imaginative. When you've come up with your example, please click on the add button. And then hopefully I will start to see what you've come up with. So like before, we do have to hit refresh to see, whoa, there we go, people are starting to do it. So if you want to see what everyone, your fellow attendees have come up with, refresh the page and you'll see them appear. If you've got a second idea, please feel free to add a second example in. Like I was saying before, the more examples we give it, the better. And as a brief aside, again, sort of thinking about what this is like in the classroom. So I spend a lot of time working with primary schools. So if you think of this project, to get this to work, you need at least, I don't know, sort of like 10 examples in each bucket. So if I'm working with like a year 4 student, asking them to type in 20 sentences is probably not realistic to do in a single lesson. But if you get 20 students to type in 1 sentence each, actually that's quite achievable. So part of the motivation for this idea of why you might want to consider creating accounts for your students to log in is by getting them to work together and make projects that might otherwise not be feasible, makes them practical. Does punctuation matter? A question in the chat. It is one of the things the computer will learn from. So if, for example, every example in this bucket had punctuation and every example in that bucket didn't, then the computer would learn to think that punctuation means fan and no punctuation means lamp. So, ideally what we really want is lots of examples of with and without punctuation in both buckets, so the computer doesn't think that that is significant. So that is, sorry, let me just. Even outside of like a classroom sort of environment, this idea of what we call crowdsourcing is really common in machine learning projects because collecting training examples is really time consuming. And it's often one of the most challenging parts of an AI project in the real world. So we quite often try to find ways to get large groups of people to each do a small amount of work for us. So if you've ever been asked when you've tried to access a website, if you've ever been asked to pick which photos have got a traffic light in or which photos have got a car in, or something like that, you're helping train a machine learning model. Because if you think of the sort of companies that do that, if they can ask 1 million people to put 5 photos in the training bucket, then they've really quickly got 5 million training examples. So they can train really quite advanced machine learning models by getting large numbers of people to do the training for them. So that's a really common technique. So let me just, so what I'm going to do in the interest of time, I will show you, so we've all made a machine learning model between us as a group, and I will show you using that machine learning model. I'm going to try and do a bit of live coding, so bear with me. I will share the instructions so you can do this yourself at a later date, but in the interest of time, I'm just going to do it quickly now. Actually, let me make that bigger so you can see what I'm doing. Once I've finished, I will explain, I'll talk through what I've done. Right, so what this is going to do is I'm going to type in a command, and it's going to give that command to the machine learning model that we've just trained. And if it recognizes that it belongs in the fan bucket, it will play a fan animation. If it recognizes, pardon me, that it belongs in the lamp bucket, it will do a lamp animation. So let's give that a try. So I'm going to click on the green flag, and I'm going to type in, I would like you to turn on the fan. Yay, there we go. And hopefully, however I phrase the command, I want the light on. Hopefully, however I phrase the command, even if it's not an example that we have used before, it will have learnt from the examples we've given it what I probably mean, and it will be able to do the right thing. I can see in the chat someone asked, well, what happened if we gave the wrong labels into our examples? Then yes, we would confuse it. Now, probably if there was only one or two incorrect ones, it probably would be okay. Now, when actually, sorry, I think in the chat the question was more about when it's in the real world. Yes, that idea of if you're trusting large numbers of the public to collect your training data, some of them might give you bad data. So what we typically do is we show the same question to several people, and if they don't all agree on the answer, we probably don't trust that, and we won't add it to our training buckets. We'll only add something to our training buckets after we see some consensus from several people have all agreed that that is the bucket for it to go into. But yeah, that's a really good point, that you can't trust a single person to give you a single answer, because sometimes people might not play nicely. Let's try this. So actually, let's see if that one that my student before did, activate the spinny thing. Turn on the light. So we've taught it to recognize a variety of ways of doing it, but you know, in similar to the way we saw with the describe the glass, what you would do is every time it gets something wrong, you would add that into the training bucket so that it gets smarter and smarter the longer you use it. Let's try a more conventional one. It's really dark. Yes. Or I'll try one last one. I'm feeling very hot. And the fan goes on. So there you go. We have trained another machine learning model. This is a much better example of when we would use machine learning. To try to do the code to do this would be much more complicated. Someone asked in the chat, so how do you tell the machine it's learned incorrectly? There's lots of ways we do this. So when we make chatbots in the real world, so if you think of when you're asking a retailer, a shop, a bank, quite often machine learning systems will have a little thumbs up and a thumbs down next to it. So when it gives us an answer, we can tell it, hang on, no, I didn't agree with that. And you can ask your users to explicitly tell you when the machine has got something wrong by getting them to click something like a thumbs down. There's other ways we can sort of recognize when people aren't happy with the answers the machine learning system has given them. Like, for example, if someone asks a really similar question again, then we know we probably didn't give them the right answer the first time. So if you ask your Alexa a question and it gives you an answer, and then you ask a really similar question straight away, Amazon have a reasonably good idea that probably they didn't give you the right answer. So there are ways we can sort of tell, either explicitly by asking users or just by sort of spotting behaviors of whether or not the machine learning systems are doing the right thing. And that's how we can harvest examples for improving the training in future. So back to my slides. So what did we do there? The AI project, so I'll come back to that question in a moment. Sorry, so the AI project we did was we got a computer to understand the meaning of our commands. And the way we did it was using machine learning. This time we worked together, but we used the same principle. We created buckets, or I set up the buckets for you, and then we all put examples into those buckets that we used to train the computer. And this is a much better example of machine learning. This is a task that would be quite difficult to do using rules. So, and I can see some questions in the chat about, are text projects maybe valid machine learning projects and numerical projects not so much? I wouldn't totally agree with that, and I'll show you some really complex numerical projects in a moment. So, but before we move on, I just want you to have a bit more of a play with that machine learning model that we've trained, because I want to, sorry, I keep getting interrupted by the chat, but it's worth answering these questions now. Yes, I will show you where you can find step-by-step instructions that you can print out and allow students to do for all the projects that we've done today. So please, can you click on the back to project link in the top left-hand corner to get yourself back to the main menu for the project? And go back to the learn and test page. That's that second button, the one in the middle. Now, what we quite commonly want to do with a machine learning system is test them. And again, if you're sort of thinking about how to explain this to your students, I would say that the classroom is a good analogy, that when you explain something, when you teach your students, when you train your students something, you want to see whether or not they've understood what you've taught them. And you do that by setting them a test. And the test identifies what they're getting right, what they've understood correctly, and what they get wrong, what they haven't understood. And then you use that to work out what other training you need to give them, what else you need to explain to them. That is how machine learning projects in the real world work. We do some initial training, and then we devise tests to see what the computer gets right and what it gets wrong. And we use that to direct more training and more teaching for the computer. So please give that a try now. Try typing in a command. So, and again, we've only taught this to understand two things: turning on a fan, turning on a lamp. So you have to ask it one of those kinds of things. And then when you've chosen the one that you want, click on the test button. And what you'll see is what the computer thinks you meant, but also you'll see a confidence score. So try doing that and see what sort of score you get for the examples you can think of. And try to, what is the example command you can think of that ends up with the lowest possible score? So if you've found something that the computer has a low score for, please share that in the chat. And I'm going to try now as well to see if I can find something that, so someone found 100%. 100% in a machine learning project is unusual in the real world. Computers are very rarely totally sure that they're right. Now, for a task, this is still a relatively simple task, so it can happen. Oh, so interesting. Someone found a 17%. Sorry, I'm just trying some ideas as well myself. So I'll show you the one I have tried. So I tried, what is the capital city of France? And the computer only knows how to predict two things, fan and lamp, so it had to pick one of them, but it came back with 6%. So what does this mean? This means that the computer is saying it doesn't know what that means. I mean, the other way of looking at this is it's 94% sure that this isn't lamp. The computer's telling you with this number that this doesn't look like anything you've trained me with before. You know, of all of the patterns I learned from, of all the examples you've given me, I haven't seen anything that looks like this before. I don't recognize this. So, and it comes back to what I was saying before. Well, what would you do when you see an answer with a very low confidence? Will those get added to the list of things that someone needs to put in one of the buckets? Because you know, I can see in the chat people have tried sweating and baking and breeze, and the computer probably doesn't have many examples of like single word commands, so it doesn't know what to do with them. So we would go back and we would add them to the buckets so that it would get better at that in future. So what we do is that confidence score is a really useful thing to us. It tells us how confident the computer is that it has correctly recognized this input, that based on the training it's been given, how confident is it that it has understood that correctly? And we use this all the time. Let me show you an example of how we use this. So I mentioned before, you know, not to use the block that said confidence, but that we would use it later. So that's what we're going to do now. So this confidence block, that's what this one does. It returns that number to you so you can use it in your project. So if I say, what is the capital city of France? What I get back from that is the number 6. So again, I'm going to try and do some quick coding to show you how we can use that. I'm just going to move that out of the way. Do if else. I'm going to do if that confidence score is less than, I don't know, what should we say, like say 60%. I'm going to get it to say, I don't understand. Sorry, I do not understand. And otherwise, if the confidence is bigger than 60%, we'll do the animation for the fan or the lamp. Oops, I want that to be there. So what this is going to do is it's going to use that number of how sure the computer is that it's correctly recognized my command. And if that number is less than 60, it's going to apologize, and it's not going to do an animation because it isn't sure that it's understood what I asked for. So let's try that. So if I try, well, let's some of the examples in the chat. There was someone said baking, so I'll do baking. Sorry, I don't understand. But if I do give it something it has learnt to recognize confidently, like I want the fan on now, please, thank you, it does still turn the fan on. So that is a really common thing to do. If you've ever had a system that has said, sorry, I'm not sure I understand, that's what's happened. It has come up with an answer, it just doesn't have enough confidence to show it to you. A lot of companies would rather not give you an answer than give you an answer that's incorrect. And maybe you set the threshold, you know, maybe if what on systems I've worked on before, what we would do is, if the confidence is higher than 80%, give the answer to the user. If the confidence is between 60 and 80%, you still give the answer to the user, but maybe you preface it with, I'm not sure, but I think it might be this, because then at least people are a bit more accepting of errors. And maybe if the confidence is less than 60, you just say, don't know, can you try asking your question a different way? So this confidence score is a really key part of how we do AI projects. So those were the two projects I was hoping we'd all have a chance to try. Before I go to any other questions, I want to show you some other projects that students I've worked with have made to give you a feel and a bit of a sense for the other kinds of things you can do. Chatbots are a really good project to do in the classroom. So similar to what we did where we trained the computer to recognize the meaning of a command, you can train the computer to recognize the meaning of a question. So, here the project was based on owls. So we sort of chose some questions that we thought someone might ask about owls, like what do they eat, where in the world do they live, how long do they live for? I can't remember what other things were. Oh, how many species of owls were there and how big are they? So we created those buckets for each of those types of questions. And then in the buckets, we put lots of examples of how you would ask that question. So you can do this for pretty much any topic you're currently doing in class. And then you can make, either in Python or in Scratch, you can make something that can understand the meaning of someone's question and then answer. So you can see here what we made is like an animated owl character that you ask it a question about owls and it can understand and answer you. Now you can, so, you know, I've done this with classes. We've made AI chatbot Romans, where you ask it about what kind of things did you wear, what kind of things did you eat. We've done chatbot Vikings, we've done chatbot Tudors. We did a chatbot William Shakespeare that we trained it to answer questions about the plays that he'd written. I've worked with a school where we made a chatbot prospectus, where we trained it to answer questions about their school, and we got their, we made a chatbot that prospective students and parents could try out, that they could ask questions about what it's like being at the school. So it's quite a nice way of, if you get your students to research a topic. Sorry, I'm distracted by the chat again. I should focus on my slides. If you get your students to research a project, whereas otherwise you might have got them to do a presentation, or you might have got them to do a talk or write an essay, an alternative you could do, so that you don't have to make the lesson about AI for the sake of AI, but getting this to be just a strand of a broader project, you can get them to present their research in the form of a chatbot, because they have to research to find out what questions people commonly ask. They have to come up with different ways people might ask that question, and they have to prepare the answers that their bot will give. So it's a nice way of sort of mixing AI into a whatever topic you are currently doing. So I've done chatbots with classes loads of times, and it goes quite well because some of them enjoy the coding side of it. Some of the more artistic students enjoy the animated, making a character that will be the avatar for the chatbot. Some of them enjoy doing the research to prepare the answers. It's a really nice thing to get a group of students to work together on, and all of them will get something a bit different out of it. And I would recommend finding some chatbots in the wild and getting your students to try it out. One that I've used before is National Geographic's one, which is about T-Rexes. And again, it's that idea of presenting information in an interactive way, which is a really good use of a chatbot, an interactive way of interacting with a large amount of information. And it's a nice, there are loads of examples of these chatbots in the world. Colleagues of mine at work worked with the British Arthritis Foundation, and they made a chatbot that you can ask it questions about how to manage arthritis and how to live with it, and how to different things that help. So it's increasingly we're finding this is a really useful thing to do anyway. So getting students to start to understand how these things are made is a really good thing. When you're creating the text project, the things that the examples have in common don't all have to be what the examples mean. Computers can learn to spot all sorts of patterns. In this one, we train it to recognize compliments versus insults. So we put the nicest, kindest compliments we can think of in the compliments bucket, and the meanest, cruelest insults you can think of in the insults bucket. And what we're training it to recognize here isn't so much the meaning, but the use of language, the tone, the sentiment. Because what all the examples have in common is a common emotion. Now, this one can go a bit wrong. I guess you kind of need to trust that your students won't get carried away with this, but it is a fun one. And what you can do is make a character that can respond based on whether it reacts. So, you can make it so that it smiles if you give it a compliment, or looks sad if you give it an insult. So here, with a little bit of training, we can say something nice to it, like, "You look lovely today," and it will smile. And if you say something mean to it, it looks sad. And inevitably, your students will all just spend the rest of the lesson trying to make the face look sad. But it's still a nice example of how we can use AI. And again, looking at how this is used in the real world, if you think of, particularly in large companies that are getting a large amount of text, being able to automatically recognize what is happy, what is angry, what is sad, what is annoyed, that's a really useful thing to be able to do. So it's a really common, either in terms of like on social media to see how people are responding and reacting to issues or their products, or even if you think of all the emails a company gets from their customers, being able to know this batch of customers are really annoyed, this batch of customers seem really happy. It's commonly used without you often even noticing. Recommendations engines are another really common example. So I mentioned, things like if you can train it to recognize what kind of videos you like, you can do similar things with text. So here we made something where it would recommend where you might want to go on holiday by giving examples of people's descriptions of their hobbies and interests. So, the sort of people who would like to go to a museum, this is what they might say are their hobbies and interests, and the same for different things. And then you can make something like this, and I've made this as an actual phone app before, or you can do it in Scratch, where you give it a description of the kinds of things you like doing, and it will make a recommendation of where you might like to go. And that's a nice way of sort of helping them see how things like Amazon or oh, I've woken up my Alexa by saying that. How things like YouTube are able to recommend what you might like based on the examples they've been given in the past. I haven't sort of mentioned image recognition. The principle is exactly the same. So you can collect pictures and use that to train the computer. So in this one, we trained it by drawing directly onto an on-screen canvas. We trained it to recognize postcodes. I mean, we didn't do the whole postcode to save time. We just did the first couple of letters, but we chose a few local cities, and we trained it by getting lots of examples of how we would write the first couple of letters of the postcode for those places. So by doing that, we collected a bunch of examples like this. And then we made a Postman Pat game in Scratch where you would write a postcode onto the on-screen envelope. And then when you click on the cat stamp, it would recognize what you've written and then send the envelope to the right van. And again, you know, the nice thing about doing projects like this is how AI is used in the real world. You know, the sorting offices, the large scale ones, do use machine learning systems to automatically recognize the writing on an envelope so they can automate the sorting. So it's a nice way of opening students' eyes up to how actually machine learning isn't a futuristic thing, it's here today, and it's used in so many subtle under the covers ways. This is a really nice example of a numeric project, actually coming back to what we were talking about before of, you know, are numeric projects really sort of proper machine learning? So with this one, what we're doing is we're training it to play the game Pac-Man. Every time you press an arrow key, you're adding the coordinates for the Pac-Man and the ghost to a training bucket for either going up, down, left, or right. So you get the students to play the game for a little bit themselves, just like we did with Describe the Glass. And then what they end up with are 4 buckets full of examples, like, I don't know, when Pac-Man was at XY31 and the ghost was at XY53, they went right. So that's an example. And the computers can use these examples to learn how to play the game. So then you put the machine learning model in charge, and actually Pac-Man's playing itself, and it's playing the way they would have played because it's learned from them how to do it. And if they've given it enough training, Pac-Man will have learned how to play the game perfectly and will avoid the ghost forever. And it's a really nice, simple example of machine learning. So I really like that project. And the students tend to like it because they have to spend time playing Pac-Man so they can train it. I'll do one last example, then we'll do questions. Images. You don't have to get them to draw their images. You can drag and drop pictures from other websites. So what we did here was we found like a library website or an Amazon website, a book selling website. We found covers of books and dragged them into the buckets. And we got examples of book covers for different genres of books. And what we did is we trained a machine learning model to recognize what a sci-fi book looks like compared with a romance book. You know, so like a sci-fi book tends to have dark covers, thriller books tend to have very large fonts, romance books, sort of pastel colors and very flowing serify writing. So those are the kind of patterns the machine learning model will be learning from in those examples. And then we showed it new examples of book covers, and it was able to predict what type of book it was from the cover. And I've done variations of this project with schools quite a few times now. Sometimes we've done it with movie posters, sometimes we've done it with album covers, but the same kind of idea. If you can collect a collection of artwork that has something in common, you can train a machine learning system to recognize what they have in common and to use that to make predictions. And this is quite a nice project, so there's not too much typing in it. It's basically you have to ask your students to go find a large set of pictures, and I found some classes really enjoy doing that. You can do sound recordings. You kind of need like headset mics for this to work. Otherwise, I found that if you try and get a large class to all do this at the same time, it gets a bit too noisy. But if you've got headset mics, these are fun ones to do. So you train it to recognize spoken words, and then you can get it to react to what it hears. So those are enough. I started by saying that there's this misconception in the general public that AI is sci-fi, AI is future, AI is robots. What I've tried to show you in the last hour or so is actually machine learning has been here for decades and is ubiquitous, and we all use these systems every day. Whether it's your phone keyboard that you've trained with the examples of everything you've typed in the past, that is using that to predict what you might want to type next, or YouTube that is using everything you've watched and thumbs up and liked in the past to recognize what you might want to watch next, or Amazon, like the Alexa. And again,
sorry, I don't have an answer for that.
There you go, low confidence score. The way we made the Smart Classroom fan lamp project is essentially how that thing was made in real life. They have more than 2 buckets because they've trained it to recognize more than just 2 commands, but the principle and the technique and the technology is the same. So that's what we've covered. I started by explaining some of the jargon, AI and machine learning. We went through making a couple of projects ourselves. And finally, I showed you some other example projects that you can make with your students. I quickly I haven't left as much time as I should have for questions. I'm going to try and do some questions now. I can see that there's some questions about how the text project that we did was trained and about neural networks in particular. So actually, let me start with my slide. So I mentioned before that there are lots of different ways of doing AI. of which machine learning is just one. Oh, sorry, I'm scrolling through all my slides. Let me get back to the start. Right. So what I mentioned was there are other ways of doing AI that aren't machine learning, and I showed you, rules are an example of the kind of thing that are not machine learning. And even in machine learning, I mentioned that neural networks is one type of machine learning, but there are others. So we tried one of the other ones this afternoon. The decision tree that we used for the describe the glass is a type of machine learning. Neural networks is what we used for the text project. And you can see that, and I'll sort of leave you to look at that later. But in the same way that you did for describe the glass, if you go to learn and test, there's a button for describe your model. And what this will do is it'll draw you a simplified version of how this works. And this will actually walk you through step by step what a neural network is and explain how it works. So I won't do that now. You can play with this later, but this will explain what a neural network is and how it used the training that we all collected. So if you want to know more about neural networks, that's the place to start. And all the terms there are links to where you can go and find more information about that. Any other questions? I'm just skimming through the list to see if I've missed any. I ended up covering more than I thought I would as I went along. What age are these projects good for? I'm not sure. I mean, I've tried it with both primary school and secondary. I would say that you go into more depth with the older children. So I showed you the one where you give it compliments and insults, and then you make something that reacts. With a primary school class, I would just do that. With a secondary school class, I would probably go deeper and look at how that's used in, for example, social networks and what are the limitations of that technology? Why do social networks find it hard to spot trolling and abusive behavior? Why is it, so you can look deeper about the implications of these things with the older children, but the actual projects can be done, I would say, spanning both primary and secondary. Someone asked about where to get the instructions. So all of the instructions are available on the website we've been using at the worksheets tab at the top. So if you go to describe the glass, you can download the step-by-step instructions for what we did today. And for all the other ones I've shown you as well. They're all on that page. To have, sorry, I'm just reading questions off the chat. Is creating an account free? Yes, it is. It's a bit of faff. You have to do a bit of setting up. So the try it now is definitely a lot simpler and quicker to get going with. But if you do want group projects, I would say it is worth spending the sort of 10-15 minutes it will take for you to set up an account. Actually, if I log out, I'll show you that now. So if you go to get started, I'll zoom in a bit. Sign up. Say that, because ideally I don't want students signing up because I don't want contact details for students. I just want to deal with teachers, so that's why it asks you this. But if you say you're a teacher, then just click on that email button. It asks you a few questions. Just basically tell me what school you're from, how many students you want to use it with, and I'll get back to you normally within a day with the details. Is there an overview of the machine learning algorithms that are used in the background? So that's what that describe your model is for. So when you click on describe your model in a numbers project, what's happening under the covers is a technique and a technology called decision trees. So it draws you a decision tree. When you're doing a text project, what's happening under the covers is a neural network. So it draws you one of them. So I've started to add to the site some things that's mainly useful for the older children, but it gives you an idea of what's happening under the covers. I think I have covered all the questions. Any others before we wrap up? No. Okay. Ray, was there anything you wanted to do before we close?
I would like to thank you for a fantastic session. I've really enjoyed it, and it's been so informative, and the way you really conveyed a lot of the machine learning concepts in the projects that you've demonstrated. Thank you so much.
Oh, thank you very much. That's very kind. And my contact details are on the site. So if you do get stuck or have any questions, or if you think of something after today that you thought, oh, I wish I'd asked, there's a forum linked off there. So you can, and I normally try and get back to people within a day or so. So yeah, if you think of something later or your student asks you a tricky question you're not sure the answer to, please don't hesitate to get in touch and I'll help if I can. And with that, I've actually finished on time, which is very unlike me. Thank you very much for joining, everyone.